Hey everybody, my name is Attila Toth. I'm a developer advocate with ScyllaDB. In this video, I want to show you MCP Toolbox for databases because in the most recent release, they added support for ScyllaDB and ScyllaDB Cloud. So let's quickly show you why you would use MCP Toolbox if you're not familiar with it and how you can use it specifically with ScyllaDB Cloud. This is an MCP server created by Google, and the reason this is an interesting project because it allows you to connect to a lot of different databases. And you really just need to configure one MCP server, and then you have a YAML configuration file where you can define how you want to interact with your database. So let's see how it works in practice. All right, so one way to use MCP Toolbox is by configuring the MCP server in your agent harness. So right now I'm using VS Code with the GitHub Copilot extension. You could use Cloud Code, Open Code, or any other MCP compatible agent harness. And this is how I configure the MCP. Then you can run prompts. So for example, we have an e-commerce project. We are storing orders of customers in our database, which in our case will be ScyllaDB. So let's have a prompt where we are asking what are the recent orders for and then the email address of a user. So under the hood, as you can see, it will actually connect to the MCP Toolbox, the MCP server, and then it will fetch data from the ScyllaDB cluster from the table specifically using the email that we used in the prompt. And then it will give us the result, as you can see here. All right, so how does this work under the hood? We have a YAML file, and here we have different tool definitions. And the one that we just tried is this one, get recent orders by email. And then here we are using the ScyllaDB SQL type, as you can see, because this will actually execute a SQL query against the ScyllaDB cluster. So we want to use the ScyllaDB SQL integration. As far as source, here we are using ScyllaDB Cloud because we have a ScyllaDB Cloud instance. If you are using some other database, then obviously you would need to use the appropriate connector type and source here. Now, very important, the description. The description will teach the AI agent when to invoke this specific tool. So when we provide a prompt, get me the most recent orders for this email, this description should match that prompt. And in our case, as you saw before, it worked well. Now, if we scroll further in the configuration, we have a statement item here. This is going to be the exact SQL query that runs against the cluster. So this is useful because this is defined right here. The AI doesn't need to come up with the SQL code, cannot make mistakes. The only variable that we have here is the customer email parameter. So that's the only value that the AI needs to extract from the prompt. All right, so now let's try a slightly more complicated example. Let's start a new session in our agent harness. And then let's say we want to run a vector search query. So let's say the prompt is find me products similar to a lightweight waterproof hiking jacket. Assuming we have a database and a table with some product data and our database supports vector search. Now, in the case of ScyllaDB Cloud, obviously, we do support vector search, so this kind of query will work. So we see the 5 most similar products returned, and we see that the MCP Toolbox invoked a tool called search products. All right, so let's see what search products is. So let's go back to the YAML file again. And then if I scroll further, we have another tool called search products. We have the description, as I showed you before. Now, one interesting thing here is that, as you can see, because we are running vector search, so we are not using the string parameter to do the search. We need to use the embedding to do the search, because with vector search, you need to convert the string to an embedding value, and then you can run vector or semantic search using that embedding value. Now, what actually creates the embedding in this example? So in this example, we are using the Gemini embedding model. For this to work, you need a Google API key from the Google AI Studio, but it integrates really, really well with the MCP Toolbox for Databases tool. So that's what we're using here. And then basically, when we provide the prompt, the AI extracts the query. In our case, it was lightweight waterproof hiking jacket. and then it uses the Gemini embedding model to turn that into an actual embedding, a vectorized value, and then that will be provided here in the CQL statement right after the ANN of operator, which will execute an approximate nearest neighbor search using the embedding. So you give your agent a prompt. Under the hood, it figures out that this is the tool that it should use to provide the response, and then it will actually run a query against the ScyllaDB cluster, and ScyllaDB cluster will run a vector search query using the parameter that you provided in your original prompt. So that is one way to use the MCP Toolbox. Another way is by using the language SDKs. They provide a Python-specific SDK, and you can call the tools that you defined in your configuration from Python. So let me show you how that's done, how we can run the same queries in Python. So basically, you create a client, there is a load tool function, and then here you need to specify the name of the tool that you want to call. And so as you can see, we have get recent orders by email. So this will use the tool that we defined in the YAML configuration file. Let me quickly run this Python script to see if it works. And as you can see, we get the same results back in the terminal by, after running the script. First, we had the tool call for the recent orders, and then we have the tool call that does the vector search under the hood, and it worked really well. All right, that's all I wanted to share today. If you are interested in checking out these tools, I'm going to provide links in the description, and see you in the next video. Bye.